So hello everybody and welcome to another video, this time about neural networks, and I prepared here, we will do this again in Colab because there are many libraries, the Tensorflow library especially, that I don't want to install on my little small laptop that I use here in order to record these videos. We run all of this in Colab. What you basically need for this course is basically TensorFlow, and this is kind of an introduction about how to build these neural networks that I've shown you in the last lecture, how to use this in a practical way, and get you a bit going on how to build a neural network, how to train a neural network, what this is all like, without going into all of the details, but just give you a rough overview about how things work to get you started. So first of all, what we need basically is, I call this plant classification. So as shown in the course, basically we are here classifying two different types of plants. You can get this data set from my website, so it's basically here we can do something like this, and the data set is called selected small cropped, because I took these images, made them smaller already, so that we have it easier to work with them, to get you started very quickly, and to get results basically in an hour for this video, so that all of this doesn't take too long. So we download these images here, as said, basically in a Jupyter notebook, or of course also here in Colab. This exclamation mark runs a shell command. There is this wget shell command, basically, which allows you to download things from the internet. With this, basically, you download this directly into this Colab machine. When I do this, I execute this here. The machine will start, as this is Colab, so we have here the backend will launch, and it will download basically this file. We see this, the download starts, the file is transferred into the Colab machine. It takes a little time, but it should be rather quick, and we have transferred this 101 megabytes into the Colab machine from my website. That's the way it works. This is a tar file. A tar file is basically something like a tape archive, so an archive of files. It's not compressed, but it's one file which contains bigger files, because the images, of course, are already compressed themselves, so compression doesn't make here a lot of sense. But in order to extract a tar file, basically you can write tar -xf on a command line on a Unix system. Here we are on a Unix system basically, and again with this exclamation mark we execute the shell command. Okay, so then we get our data set. So so far so good. This will put some output here, but basically we have our files here. If we go here into our file section, we see we have this folder selected small crop. And if I go into this, I have two flowers, so flower A and flower B. And basically what we want is, we want to have, we want to see basically that we want basically to classify the flowers. Yeah, so the idea is basically to say, okay, if I show you an image of flower A, tell me, is it flower A or is it flower B? It's kind of the same thing as the cats and dogs example, just that we have here flower A and flower B, and we want to build an image classifier using neural networks, as we have seen it in the last lecture, basically. Yeah. Okay. In order to work with this data, there are several tricks, and also basically this is why it's also kind of called TensorFlow. This library, because the question is, of course, if you have a lot of data, how can you handle this? How can you get this data into RAM? How can you pre-charge the data so that kind of the training always continues, because probably your data set is bigger than what you can fit into memory of the machine, or at least what you can fit into the GPU. So you always need to pre-charge some data into RAM while you basically train already. And TensorFlow has several kind of ways in order to do this, and here basically we show you how to handle images with TensorFlow, how you can work with images and how you can get these pipelines kind of running up. So the first thing what we will use is just to show you some Python features again. So there is basically a pathlib, which allows you to work with folders and files. And basically we have then here data dir, so let's say this is the directory where we have all the data, and we can do something like pathlib path and say, okay, this is selected a small, let's turn this here off, cropped, okay, so this is the folder that we've just seen before. And basically we open kind of this folder in here, and then we can work with that. How can we work with that? We will see. So the idea is basically what we want to do. We just want to count basically how much images do we have under this directory, how many images do we have to classify. And we can see basically if we run this here, then we have this kind of data directory structure, and then we want to dive into this directory. So what I want to do is I want to count the images, as I said, so I can do something like this, image count, and I can say the length, and I want to have a list basically of all the files that are in here. And this can be done with this glob functionality, and we can do something like star/star.jpg. Yeah. So what do we need to know here? So first of all, you're on a Unix system. So on a Unix system, basically directories are separated by / for those who are not familiar with it. This is basically the current folder / this one. When you work in Colab, basically the current folder is this kind of contents folder, in which you are in by default, and where it downloads basically this file where we created this directory by extracting this archive, where our images are in, as we have seen here. Let's recap in the tree. So we have this flower A and flower B, and there are a bunch of JPEG images basically of these different type of images of flowers. Yeah. Okay. So fine, so good. Right now with this way, basically I can say, okay, dive into all directories, show me all JPEGs. So this is basically flower A, flower B, and then basically inside all the images. And it generates me of the list with this glob functionality of all these images. And of course, if I take the length operator on that, then I know how many images I have. Okay. Very easy, all of this. Image count, how many images do we have? We have 6,886 images that we can use for our training. Okay. What we want to do basically here is we want to generate some kind of flow, so to preload automatically these images while we train on them. And in order to do this, there's kind of an image generator. But before we can use this image generator, I want kind of use this again and show you some more Python functionality, and want to get the class names out of it. And the class names, of course, in this case is we have two flowers, so the class names will be flower A and flower B, and we just basically want to use this kind of glob story here, this list story here, in order to generate the class names, so that you can see how you can work with this. So basically we will use the NumPy library in order to work with this and generate the NumPy array, as we need this for our TensorFlow story here. And we say here class names, I will call it like this, NumPy, and we build an array, and we say, okay, this is a very easy way to do a list, so that you have seen this also once. So I want to have a list of item names for, and I can say basically item, yeah, in data dir this is basically called, as I launched this with pathlib, and we use again this glob functionality, and we don't dive into the subdirectories as we did it before. we just call it like this. Okay, so we use this wildcard here, which gives us all directories, as we omitted the slash and this .jpeg just as above. We don't dive into it, we just get basically these two directories out, and this generates us a list, yeah, so that you get also the idea about of how this works. So we then basically get items out, these items have a name, and we get a list of these item names automatically by this operator. So every time you can generate basically something from or an object which is kind of an iterator or a list in itself, and then you want to generate something out of it and create a new list, you can kind of use this type of syntax, so that you're also familiar with this, which is very frequently used in Python. Okay, so fine, so good. We're still not at deep learning, but we come to it right away. So when I go here, when I look at my class names, I have flower A and flower B, which will be, of course, the targets for our classification problem that we have here, that we will solve with a neural network. So right now we start to import the deep learning library. So let's get into TensorFlow. So import, how do you get this? Import TensorFlow. Here, very nice, TensorFlow STF. If you have it installed on your machine, you can do this, of course, on your machine. Here we do this in Google Colab, and we have the TensorFlow library loaded into our IPython notebook. Okay, so fine, so good. What we want to do right now is we want to build an image generator. And we want basically this image generator, it kind of will care about these flows, yeah. So image generator, we directly take this out of the library. So this is found, there is kind of the Keras subsystem which has been integrated into TensorFlow one day. And we see here there's this Keras system, it has something pre-processing libraries, just like as scikit-learn. Of course, here we are working with neural networks, so this is not really related to scikit-learn, but we have this pre-processing story here. And we say image, and we want to have an image data generator, okay? So we have this here, and we will say this image data generator, we can give it some objects already, and we want to say rescale 1/255. Why do we do this? So basically each image has like 255, a range of from 0 to 255 normally for each color. So in red, green and blue if it's a 24-bit image, even if it's a 32-bit image, because then the fourth channel is kind of just also from 0 to 255 an alpha value, so how transparent this kind of pixel is. In general, that's the way it works. There are, of course, already 16-bit images which have more color depth if you want to, or even floating point images which use floating point numbers in order to store the color depth. But in general, in computers still today, and most of the people's eyes basically don't also capture a better color space. You have 255 values for red, green and blue, and as in these neural networks you want to have values that go into it between 0 and 1. We just rescale this by dividing these values by 255 so that we get values from 0 to 1 out. Okay, very easy to understand. We have here our image generator. This is this image generator, and right now we will use this image generator that we have prepared basically to generate a flow from this flower data set here so that we can train from it. So the images, you can download one of them here. So if we have this here, let's do this. So we have our selected small cropped. Let's dive into flower A. It takes a bit time until it gets here something up and running. We have here several images. Let's download one of these images. And if I open these images here, Hang on, I download my image. If I open this image right now, let's do this, downloads, and we can watch into this image, and we see this here is basically this small plant, and the other plant, of course, it looks a bit different, and you can get from these images basically, let's check out an image of the other plant so that you see that too. Flower B, come on. Basically what I wanted to show you is that this is the size of these images, and these images are rather small so that we can train quickly on them, but they contain more than enough information in order to build basically this classifier. Okay, so we have the second image downloaded already, so I have to open it. Let's open the second image, whatever it's named. So it's the 16,001, and we see that these two images, if you put them side by side, that they look quite different, that this plant basically here has this kind of leaf structure, while this other plant also has this, it's more like an older plant which has this kind of different leaves here, and basically we want to distinguish this plant from this plant, and we have a bunch of images, 6,000 images altogether of both categories, and we want to classify these images. And these images, they have of course a certain size, so you can trust me on this. You can look this up with your image processing program, but you will see that basically the size of these images is in height 300 and in width 180. Okay, and then we have our generator, and it's the image generator, and here we have a flow from directory, and basically with this flow from directory, let's make this here like this, we can generate a flow, so it can kind of TensorFlow while it trains, it preloads the images. Okay, so this is how to work with images. Of course, you can basically train with arrays and with NumPy arrays and all these kinds of things if it fits into memory. If it doesn't fit into memory, you have kind of to build your generator. There are different ways in order to build generators. Here I show it you just for images so that you get kind of a feeling of how things work, how things are going on. Okay, so far so good. So we say we need for this a directory where our images are in, and of course we can use the data directory that we have up here, and then we can directly say okay, we give this here a bunch of parameters. We say, for instance, target size. This here is height and width. They want it in this nomenclature. Don't ask me why, but that's the way it is. And we say color mode. We want to have it in grayscale because we want just to divide by 255 and not make up 4 color spaces and something like this. So we automatically can kind of convert this to grayscale using that way. And we can say classes, and classes we just say list class names, and it will understand that basically these are the two classes that we have, and take it out of this data directory. And if you build something, if you build basically a classifier, image classifier with your own images, you can follow kind of my way around, and you will get go into the right direction. And then we have batch size, so this is basically how many images it loads at once here, and we will say 30. Okay, so fine so good. This is our image generator. So what can we do with this image generator? We can load a bunch of images into the story here. Maybe I have written something wrong here. Positional argument follows keyword. What's going on here? Target size. This here was wrong. It was missing the equal sign. Okay, we have our images. We have 688 images belonging to two classes. You see how things go. Okay, just visualize a bit the images in here. also to get a bit more out of this visualization and functionality that you have in Python again. So let's use the matplotlib. Import pyplot as plt, and then we will basically create us a little function in order to get a bunch of images out of this generator here. And we will say image batch and the label batch, so let's do it like that. And we want here basically something like this. I will program it and then maybe we will comment on not yet what we're doing here actually. So for n in range, let's get 10 here, and let's do something like we take the axis here and we generate a plot, a subplot, and we can say here 5, 5, n plus 1, and we want to have plt imshow image batch, and we want to have the nth image, and we don't want to see the axis here. Something like that, and then basically this is kind of a function in order to get a batch out of these images and visualize a batch of these images. Very easy to understand. So we generate like a figure with this kind of size here. It is and we will basically say, okay, we want to have basically 10 images like that, and basically we want to generate a plot with 2 times 5 images, and then we basically want to plot them here, yeah. As easy as that. So here we have defined this function, and then we can basically use this generator as an iterator and get just one batch out of it. So let's get a batch out of it here. So let's call this here image batch and the label batch. And basically this should be, as the batch size is 30, it should be 30, but I will just show you 10 images with this function that we've created it here. But this doesn't matter, so we call this here the generator. So with this next, you can basically from an iterator get out the next number. You could try this out with different iterators that exist in Python. This is also some kind of syntax that you should kind of memorize, okay? So fine, so good. So next gives you the next item from an iterator. You can use this, of course, in a for loop. Here we use it like this. And then we can use our show batch function here. And we can say image batch and label batch. And here, I am not sure if this will work. Maybe we have to reformat this a bit. No, it works perfect. So here we have our images, so we have our 5 images, as I've told you, and you see basically that, I mean, with the eye you can see that we have 2 different plants here. Of course this is here in false color because it's grayscale, and according to the density this is a bit color different, but you see that this plant here is different from this plant, and from this plant, while this plant and this plant is probably the same here and the same here. While these plants here are kind of different plants, and we want to classify basically if it's either this plant or this plant. Yeah. Okay, so fine, so good. So we see that our image generator works. We can test this in this way, and we can go to neural network building, so to the core of this whole story. So yeah, you need a lot in previous in order to generate these flows, but this is kind of one of the most important things also in deep learning, is not only building the neural network, training the neural network, but also having ways how to get the data in a decent way into the neural network, how to show it to the neural network, how to build a pipeline so that basically fast enough the images go to the neural network, things like this, so that you get a feeling for this. So right now we need our TensorFlow library in order to build this kind of image classifier. So we will do this here. So we use TensorFlow, Keras layers, and we will import basically a lot of stuff. So we need an input layer. So these are the layers that we will use, as if you remember from the slides, basically what these neural networks look like. So we will have an input layer. We will use basically the dense layers, which is the classical neural network layer. We will also use something which is called flatten and something which is called reshape. So these are not really layers from the neural network, let's say it like this, but these are basically things that allow us to get from two-dimensional objects to one-dimensional objects, to change the shape of our tensors, let's say it like this, of how the data is represented between one layer and the next. Okay. So far so good. We need more layers, so I will just copy paste this. So I will just write it that way. We could have written this all in one, but just to basically so that you can see it on the screen also. We will import here the two-dimensional convolution, the dropout. The dropout is basically a mechanism in order to perform regularization. So using the dropout, basically you can hide parts of the neural network during the training phase, and so only parts of the weights will get updated and not all of them. And this way, basically, you regularize your neural network. You prevent kind of overfitting of the neural network. So we will also use this dropout, so that you have heard about this. Further, some more layers again, not only the convolutional layer. So we talked last time about convolutional neural networks. We will eventually build here a convolutional neural network with at least one convolutional layer. And we say here we want to have basically a concatenate and the max pooling. So the concatenate allows you to basically concatenate data from different layers together in one way or another, to link things together. And we also talked about the pooling. So if you remember, it's basically just if you have a 2D image, taking in this case the maximum pixel out of 4 pixels, for instance, or of 9 pixels, and say, okay, this is the new pixel in my new image in the next layer, which just basically downsamples your image. Yeah? So this is what we do here. Okay, this is one thing. This is kind of the architectural parts. These are kind of the building bricks for our neural network that we will build. Then we need an optimizer and a model. So this kind of goes hand in hand. But once you build the neural network, you then have to kind of name it as a model. And then we need this basically this optimizer in order to train the neural network. And the optimizer is basically this gradient descent. Here in a more elaborate version, which is called the ADA delta. You can look it up on the web. This kind of implements also something like momentum when you go down the hill, not just only by this derivative, but basically when you go down, you kind of continue a bit in the same direction, and only shaped by the new direction that you find using this gradient. Basically, it's a more advanced version of the gradient descent that you've seen during the lecture. Okay, so from TensorFlow, not TensorFlow, models import. We want to have the model, and we want we will use this ADA delta minimization algorithm in order to minimize the loss function. Okay, to say it like this. Okay, so right now we have all the tools in order to build our neural network. Right now we need to build a neural network, and we will do this here together. So we have basically to get some layers down and stack these layers on top of each other, just as we have seen it in the last lecture, where we had kind of these nodes and weights between the nodes, and also this kind of convolutional neural networks. So these convolutional kernels, and all of this stacked up on together. And right now we will kind of create the architecture of this neural network. Okay, so our images, they have a width and a height. So this is already, we know this. So we define, using this width and the height, the shape. The shape for a tensor is always like this, especially when you work with images. So it's kind of three-dimensional, but we have here one. Okay, you could have here, for instance, 3 or 4 if you work with color images. This is a good input shape that we can work with. Okay, so we start with the input layer. So we will call this inputs, input image, and this input image uses this input layer that we have up here, where we basically say, okay, shape, the shape of this input should be the shape as here above, and we can use this basically in order to run our stuff. So okay, so right now convolution, and we say we have 2D convolution, so we use our convolutional neural network here. And what we will do, basically we say filter 7, so we want to have 7 convolutional kernels. I told you last time that there can be more convolutional kernels, which basically will generate us like 7 images out of one image. And we will say the kernel size, it should be 3, so we have a 3 by 3 matrix basically, which goes over this image, which acts as our convolutional kernel. To recap this from our last session. Okay, so if you don't know what's going on here right now, then go back to the previous video. We have a kernel of size 3, which is kind of this matrix which creates an inner product for each pixel, which runs over the image, and we have 7 images, 7 kernels like this, and we will generate these 7 images kind of out of them. Yeah. So input shape, is the shape. Okay, and then we say padding should be the same. So this is kind of how you handle the matrix overlap in the edges, something like this. And here we say our input image. Okay, so how does this work? Just to get this clearly here, so basically you have here this kind of function which has these arguments, and here you have a second argument, and this argument then always has to be the previous layer. Okay, and then so in the next layer, in the end, I will have I will have this argument here. It will be this one here. Yeah, so you can stack this on top of each other in order to build this neural network, and this is what we will do here. Okay, so what does the next layer look like? The next layer looks like max pooling 2D, and we have here pool size then, and the pool size should be 3 by 3. So far so good. Okay, what am I doing here? I have 9 pixels, and out of the 9 pixels I take the highest pixel, and this way I basically downsample my images from the previous layers, and I perform this on this convolution. No, very easy. And then I want to flatten this whole stuff. Into a 1D object from all of the values that I kind of have then from these 7 images, which kind of got 3x3 pooled and downsampled, and then I want to go into a dense neural network in order to show. Of course, I could here stack up another convolutional layer, do all kinds of things, build different architectures. Here we stay with something simple so that you get kind of a high-level overview about how you could write things, that you have something to get started on if you want to build your own neural network, okay? That's what we want to do here. Okay, so right now I called this then encoded, and we're out of this convolutional part, and we go very easy. We will build our classical neural network, and this is basically just this dense operator. And then how many nodes do you want to have in this layer? So we say 128. You remember that we had these activation functions, and I say here we will take this rectifier linear unit that we had last time, if you remember it, and we say encoded. Okay. So fine, so good. We have this here, and we will basically on this in the next phase. Let's stack up some layers here, and let's do it like this, that this here should be only then 64 nodes, and then we get another 64 nodes, so to have some kind of several weights in between, and in the end we want to have just 2 nodes because we want to classify, okay? That's basically it, and here maybe we want to have this a bit smoother, so we can use here the sigmoid function in order to maybe classify a bit better, yeah. That's here kind of the idea, and we already talked about this dropout, so we also want to have this dropout node in order to overfit and in order to train better, and we can say here basically, let's give it a try. I hope that this model will work well, so we have dropout, and we can say 0.3, and we want to have encoded stuff here, and here again we do this again, and we say encoded dropout 0.3, so 30%. We hide of these two of the weights between these layers, in order when we train our model, and when we calculate new weights of our model using this backpropagation algorithm, if you want to, yeah. Okay, so right now we have our model, and in our model basically we have then to define, okay, our model will consist of these layers, so this is very easy. So you start basically at input image, so you have to tell it the begin and the end, and then we have here model, basically we have to tell the model what kind of optimizer it uses and what kind of loss function, and the optimizer, as we said, we will use this other delta, which is basically nothing else than a gradient descent in a better, more performant way, and as the loss function we use the categorical cross entropy that we have not imported, but we can directly here write it out. So there are losses, and then we have here categorical cross entropy. No? Okay, and the categorical cross entropy is kind of something very, very nice, because it uses kind of a logarithmic function in order to make it so that basically that there's a huge impact if it's in the wrong box. Yeah. So basically to really push things into the right box. So if you have some kind of classifier where you put stuff into boxes, you can use this kind of categorical cross entropy loss function. It works very well for such cases. And then we want to evaluate in each step. So we have metrics that we can basically see, that we can investigate during the training phase, and we want basically the accuracy. So how often we put things into the right boxes, and how's it going, okay? So fine, so good. This is our model, yeah. So these are basically the layers here. This is basically then the optimizer. This is the loss function that we have. We optimize this loss function basically in each step for every time we show it an image. And right now we will basically use this kind of flow that we have generated above in order to train this network, okay? All of this is really nice. Pool size, we have to have here equal sign, and our system here is defined, okay? This is all very nice. Right now we want to go into training, and we can basically start to train here with this model fit function, and we can use our generator, and we will say batch size. Let's make the batch size a bit smaller than. So in here the batch size is different than the batch size that we have seen in the generator. Here it's basically how many images I show kind of at once to make a gradient descent step. So if I have batch size of 1, I make kind of a descent step with each image. Here I kind of takes like 10 images to get one descent step, okay? The batch size is of course a hyperparameter. Sometimes it trains better if you just use one, and but it's then of course slower if you use a batch size of 10. I guess in this case it's very well. And we will say epochs, and we will train. Let's start with 10 epochs. So epochs is how often you will show the whole data set to then the neural network. Several times you have to use a lot of epochs in order for the model to converge. In this case we will just use 10 here in order to get things started and see what will happen. So it starts to train, hopefully. It trains very slowly as we have basically no GPU here, I guess. This is poor CPU training. And we see it trains rather slow, but we see that the loss basically decreases as it already trains on the new images that it finds, and that the accuracy is still pretty bad, because basically we're at 0.5, which is like 50-50. So basically we could roll the dice, but we say that it gets better already here during the first training, and the more often we show this probably to the neural network, the better it gets. Okay, let's stop this here, and basically what we will do here is we are doing here poor GPU training. So you can basically here, if you have this kind of collab here, you can say change runtime type. Hopefully you have a GPU in your machine, so we can see here we will use the T4 GPU, then it will be a bit faster, and we will save this here, and we're connecting to this new machine. And I'm not sure if we could keep we lost our data, so we have to re-download everything and rerun everything, but basically what you can do here is run all, and then it starts everything from the beginning, and it will hopefully be very fast, so that we get our training running, okay? So we download right now the images again, and we see that all these commands are pretty fast to evaluate. We see our batch here, we see our TensorFlow, and we start training. And we see this, as this is right now the GPU, how much faster it already trains. Yeah? So very quickly here it started. So just to know, to also right now you have seen kind of the difference between a CPU and GPU training. and how much faster it really trains here on the GPU than instead of on the CPU. And we see that basically our model here seems to converge. So we are already here, basically we made one epoch more because we already kind of adjusted the weights. I'm not sure if it stored them, but maybe not. So we do here our 10 epochs, and we see that after 10 epochs here we are already at 70% correct, and we will get probably way higher numbers. Of course, what we omitted here is, as we did this, there is no training set, test set strategy, which is of course something that you would have to implement. So you would have to here train on a training set, see that on the training set you get a good accuracy, then validate this accuracy on a test set. At least we don't have the time for this. I guess I hope you basically have got an overview about how all this works. I will wait until this here finishes, and then I will just show you, of course, how you can use this in order to make predictions, so that you can implement and by hand basically training test set splits, or basically cross-validation even, if you like. So we see here in 10 epochs, of course we could run this longer, then this would fit probably better. We see that we are still here having convergence going. And our model is basically trained well, at least to an accuracy of 0.75 in predicting the right plant if we show it an image. If we ran this longer, the accuracy will increase up to a certain point, then sometimes it will stall. This is not always a given that this converges. Hopefully it converges, in this case it should converge. And then of course you would have to have a test set in order to test if this accuracy is right, and you can basically use, there is this model, you have then kind of this model predict function, where then you can show it basically an object in the right shape, so an image, so a NumPy array height width like this, in a shape like this, that you can generate from an image, and then it will basically give you a value if it's in the first box or in the second box, and you can use this predict in order then of course to basically to see if you have the right accuracy. That's how it works. This is all that I wanted to show you here for this kind of so that you have an idea how you can build neural networks, how easy it is today already. So how you can build a neural network with this TensorFlow library from Google, how to use this in your own projects. I hope right now you have a rough idea about how everything works. Don't take everything here for perfectly granted, because as I told you, well, if you do this here, you build your model. You've seen how you can build your model in very simple ways, how you can train your model. Of course, here is no test set, training set that you actually need in practice. You also need cross-validation. You might want to use cross-validation in practice. Of course, this takes a long time. For this video, we don't want to do this. I hope you had an overview about how to build neural networks with TensorFlow. This was kind of the idea of this video. Have a nice evening and goodbye.